The Gridiron Pendulum. It's an amazing invention from the 18th century that made clocks much more accurate by dealing with temperature changes. It was created by British clockmaker John Harrison around 1726, but it was later improved by another clockmaker, John Ellicott. In regular pendulum clocks, the length of the pendulum can change with temperature. When it gets hotter, the metal rod inside the pendulum expands, making the clock run slower. When it gets colder, the rod contracts, making the clock run faster. This fluctuation causes the clock to be inaccurate. The gridiron pendulum solves this problem by using rods made of two different metals, usually steel and brass, which expand and contract at different rates. These rods are arranged in a way that their expansions and contractions cancel each other out. This means that the overall length of the pendulum stays the same, regardless of temperature, keeping the clock extremely accurate. During the Industrial Revolution, these precise gridiron pendulum clocks were essential in factories, labs, office buildings, and post offices. They helped keep work on schedule and other clocks synchronized. The design became so associated with accuracy that many clocks featured decorative gridiron pendulums, even if they didn't actually need temperature compensation. However, by the 1800s, scientists figured out that the gridiron pendulum had some flaws. The rods, when adjusting to temperature changes, would move in small jumps because of friction. This caused the clock's accuracy to shift suddenly. Also, early versions used zinc, which was found to be unstable and would change shape over time. Because of these issues, the mercury pendulum was developed for high-precision clocks. This used mercury, which was very predictable in its expansion properties, ensuring even more accurate timekeeping. John Harrison, who also made great advancements in marine chronometers to help sailors determine their longitude at sea, initially created the gridiron pendulum as part of his broader efforts to improve clocks. John Ellicott later refined Harrison's design, making it even more reliable. These gridiron pendulums were so accurate they were often used in astronomical clocks which track celestial events, and they were adopted by many observatories around the world for their superior precision. The principles Harrison developed for the gridiron pendulum also influenced the design of marine chronometers, highlighting how improvements in one area of timekeeping benefit others. These are Interesting Things with JC.